Hello to my Algebra 2 people out there. This is Mr. Hotard. Today, our lesson is going to be on solving 3x3 systems of equations. All right, before we get into that, we're just going to do a quick review from Algebra 1 of solving what's called 2x2 systems of equations. When you have two equations with two variables, how do you find what x equals and what y equals to satisfy both equations? Now, there's multiple ways of doing this. What I'm going to review right now is called the elimination method, where you can just cancel something out. If you notice, right now everything lines up. I can't just cancel anything out right now, but I could if I changed some numbers. Like here, there's a positive 15x. If I had a negative 15x in this equation, then I could just add these equations together and cancel them. But the nice thing about algebra is you could do whatever you want to one side of the equation as long as you do it to the other. So if I want this to be a negative 15, then I could just distribute, let's see, negative 5 times 3 would give me negative 15. So I could just distribute 3 to this whole top equation, and that would allow me to cancel these things out. Now again, I'm multiplying by 3 so that I get a negative 15 here, so I can cancel out with positive 15. That's why we call it elimination, to eliminate. So let's just distribute that. So that's going to give me, I'll just write it underneath here, that's going to be negative 15x plus, that's a 15, 3 times 8, 24y, equal to 3 times negative 24, that is negative, what is that, 72. So now, I'm ignoring that top equation, now I'm working with these two. All right, now I can add these two equations together. 15x and negative 15x cancel out. 6y plus 24y, going to give me 30y. That's going to be equal to, let's see, negative 18 plus negative 17 is going to be negative 90. Now it's easy to solve. It's just divide by 30, solve for y. Y equals negative 3. Now we're not done. We found y. What do we still need to find? X. So I'm going to go back and plug it in. It doesn't matter which equation you use. All right, I'm going to use the top equation, but either one will work. I'm going to plug in negative 3 for y. So negative 5, negative 5x plus 8 times negative 3 equals negative 24, and I'm going to solve that. So 8 times negative 3, so negative 5x minus 24 equals negative 24. Let's solve for x. So add the 24, cancels out, negative 5x equals, and it cancels out here. It's just equal to 0. So then when I divide by negative 5, x equals 0. So my final answer for this problem was 0, negative 3. So now I want you to use that same method, try to solve number 2. So go ahead and pause the video, try to solve number 2. Did you do it? I hope so. The answer, by the way, should have been for number 2, x is 1, y is 0. So let's look at how you would solve that. Now, you could either cancel x's or y's. I'm going to cancel x's. So I want this to be a negative 12. I would distribute positive 2 to this second equation. So I would now have, let me just rewrite the top one, 12x plus 2y equals 12. And the bottom equation is now going to say negative 12x plus 2y equals negative 12. And then when I add the equations together, x is canceled, that's a 2. 2y plus 2y is 4y, and 12 plus negative 12 is 0. So divide by 4, y equals 0. That doesn't mean no solution, it means y equals 0. And now go back, plug in that y number into either equation. Looks like the second one would be easier to use. Negative 6x plus 0 equals negative 6. So I can ignore the plus 0, just divide by the negative 6. X equals positive 1. So my answer here is 1, 0. So that's the elimination method you learned about in Algebra 1. Now, look down at the bottom of the page. We're going to be looking at what if I have what's called a 3x3 systems. I need to solve for x, y, and z. Oh my goodness. So I'm going to give you the steps first. We're going to be following the same 5 steps in every problem and just go through that one thing at a time. So all these, let's just list the steps first. In all these problems, first thing I'm going to do is just pick 2 equations. Pick 2 equations, and I'm going to eliminate one variable in those equations. Doesn't matter which variable, whichever one looks easiest to do. Eliminate one variable. Okay, so if I look at example 4 right here, it's really helpful if you number the equations 1, 2, and 3. That way it's easier to follow in your work what we're doing. So I'm just going to use equations 1 and 2. I don't have to start with those, but those look easy to work with. What's the easiest variable to eliminate in equations 1 and 2? The x. They already cancel out. So let me just line up equations 1 and 2. 4x plus 6y minus 6z equals 12. And we have negative 4x minus 2y plus 3z equals negative 4. So let's just add those equations together, cancel out the x's. So 6y minus 2y is 4y, negative 6z plus 3z, negative 3z equals 12 minus 4 is 8. So there's step 1. Now step 2, pick 2 different equations. Pick 2 different equations and eliminate the same variable. And that's crucial, all right? Since we eliminated x in our first set of equations, I need to eliminate x again. Don't eliminate x the first time and then y the second time. You'll hit a dead end. So now I can either use equations 1 and 3 or 2 and 3. Which set of equations looks like it'd be easier to cancel out x? Definitely 2 and 3. They already cancel out. So let's use equations 2 and 3. So I'd have negative 4x minus 2y plus 3z equals negative 4, and positive 4x minus 2y plus 2z equals negative 4. We can just go ahead and add these together as is. So x is canceled, that's negative 4y, that's plus 5z, and that's negative 8. So I've done my first step, I picked 2 equations, eliminated a variable. I did my second step, I picked 2 different equations, eliminated a variable. Now, look what I have. I have 2 new equations right here. I'm going to solve this system. So step 3, solve the 2 by 2 system for one variable. For one variable. So let's just put these 2 equations together. We have 4y minus 3z equals 8. We have negative 4y plus 5z equals negative 8. So now I can solve that. I don't even have to distribute anything. Look, the y's cancel out. This one's nice. So let's just add these together, cancel out the y's. So with negative 3z plus 5z going to be 2z equals 8 plus negative 8 going to be 0. All right, so now that's easy to solve. So now after I've done that, I'm going to solve that and I'm going to divide by 2. I know z equals 0 divided by 2 is 0. So there's part of my answer. All right, that's the hardest part, is getting to that first part of the answer. Now, do I have to do all this work over again to find x and find y? No, I don't. All right, just like in the 2 by 2 systems, once you know one answer, you can plug it back in to find the other. But make sure you're plugging it into the right thing. Once you know one part of the answer, step 4, let me just write it over here on the side. Step 4 in all these problems is substitute into a small equation. Substitute that answer we found into a small equation. Don't go back and put it in one of the original ones. If you plug in z, you'll still have an x and a y and you'll hit a dead end. Go back to one of these little equations, plug in that 0 in for z. So it doesn't matter which one, I'm going to use this one. So I'm going to say 4y minus 3 times 0 equals 8. 3 times 0 is just 0. So I'm getting 4y equal to 8. Divide by the 4. Tells me y equals 2. So now I know z, I know y, what's left to find? X. So my last step, now I know 2 of these answers, my last step in all these problems is to now go back, substitute into a big equation. Any one of the big equations should work. So I know Z, I know Y, so let's see. They all look pretty similar. I guess it doesn't really matter which one I use. So let's just use the first one. Let's go back, substitute into equation 1. All right, equation 1, I have 4x plus 6y, so 6 times 2, minus 6z, 6 times 0, equal to 12. So 6 times 0, that's just 0. I can ignore that. 6 times 2 is 12. I've got 4x plus 12 equals 12. And then subtract the 12. 4x equals 0. Divide by 4. I know x equals 0. So my final answer for this problem, problem number 4, would be, I want to put them in alphabetical order, x, y, z. So my answer, I'll just write it up here, would be 0, 2, 0. All right, so I'm going to be following those same 5 steps for all these problems. So example 5, let me just draw myself a little line right here so I'm not mixing up my work. It takes a lot of work to do these one little problems. Okay, example 5. If at this point, if you want to pause the video and try to work this yourself, you can, if you understand what you're doing, and then go back and check it. But if you need another example, here it is. We're doing it. So let me just number these, 1, 2, and 3. I need to cancel out. I need to pick 2 equations, eliminate a variable. Now it looks like it'd be easiest to use equations 1 and 2 and cancel the r's out this time. So let's do that. Equation 1 and 2, I have 6r plus s, just be careful you're not making your s look like a 5, minus 6t equal negative 23. And then equation 2, negative 6r minus 3s minus t equal to 0. So we can already cancel out the r's, so let's just add the equations together. Cancel out r's, so that's going to be negative 2s minus 7t equal to negative 23. So there's step 1. Now step 2, I want to pick 2 different equations, eliminate the same variable. What variable did we just eliminate? R. So I'm going to pick 2 different equations, and I need to cancel out r again. Now would that be easier to do in equations 1 and 3 or 2 and 3? This time it's easier to use equations 1 and 3, all right, because I have a 6r and a negative 6r. So let's use equations 1 and 3 this time. Hopefully I have enough room to squeeze all this in. So I'm going to have 6r plus s minus 6t equal to negative 23. And I'm going to have negative 6r plus 2s minus 4t equal to negative 4. And then the r's already canceled, so we could just add these equations together. Cancel out those r's. 1s plus 2s is going to be 3s. And then that's going to be minus 10t equal to negative 27. All right, so we did step 1. We've got this equation. Let me just underline it so it's easier to find. We did step 2. We got this new equation. Now step 3, put those 2 together. We need to solve the 2 by 2 systems. So let me just bring this one down underneath here. Negative 2s minus 7t equal to negative 23. Now this one, I'm looking at these 2 equations together. This one's a little trickier to solve because nothing cancels out when I just line them up. I need something to cancel, just like in these first problems, how we had to distribute something in order to make them cancel. Sometimes you had to distribute to both equations. So if I want to cancel out s's, that's probably the easier way to go. All right, I have a 3s here, a negative 2s here. I'm going to have to distribute something different to each of these. I need to basically turn these into their least common multiple of both of these. Think about it, if you count by 3s, 3, 6, 9, 12. If you count by 2s, 2, 4, 6, 8. What's the first number to show up in both those lists? It's 6. I want to turn both of these into a 6s. 6s and negative 6s. So what would I have to distribute to this first equation? I need to distribute 2. 2 times 3 would give me 6. And what would I have to distribute to the second equation? I'd have to distribute a 3. 3 times negative 2 would give me negative 6. So I'm distributing something to both of these. Let me just bring it down underneath here. So first equation, 2 times each of these, will now say 6s minus 20t equals negative, what is that? That's going to be 54. And then the second equation, I'm multiplying by 3. That's going to be negative 6s minus 21t equals going to be negative 3 times 23. That's going to be 69. All right, now we can add these equations together. I'm going to cancel out the s's. Negative 21t plus negative 20t going to give me negative 41t equal to negative 54 plus negative 69 is negative 123. And then divide, now I can solve it. Divide by negative 41 gives me t equals, that's going to be positive 3. All that work. But once you have the first part of the answer, it's downhill from there. Once I know that, so I've done steps 1, 2, and 3. Step 4, should I plug that now into one of the big equations? No. What's step 4? Substitute it into one of the small equations. Go back to any of these little equations we found, plug in that 3 for t. So let's use this little equation right here. I'll just bring it up here where I have some room to work. So I have negative 2s minus 7t, so 7 times 3 equal to negative 23. Now let's solve that. Negative 2s minus 21 equals negative 23. Let's solve for s. Add the 21. Negative 2s equals negative 2. Divide by the negative 2. That's going to give me s equals positive 1. So I found t, I found s. My last step is to find r. Again, last step in all these problems, go back to one of the big equations. Plug these in. Doesn't matter which one you use. All right, I guess, I don't know, maybe I'll use that first one. All right, so 6r, let me just write what I'm using. I'm using equation 1. 6r plus s, so plus 1, minus 6t, so 6 times 3, equal to negative 23. I'm just running out of room here. All right, so negative 6 times 3 going to be negative 18, and I can combine these like terms. 1 plus negative 18 going to be negative 17. 6r minus 17 equals negative 23. Solve that. Add the 17. 6r, I'm mixing up my words. So 6r equals negative 23 plus 12 going to be negative 11. No, negative, that's a 17 rather. That's why it's important to be able to read your own handwriting. So that's going to be negative 6. I had a moment there. Okay, and then divide by 6. R equals negative 1. So final answer for this problem, put them in alphabetical order. R, S, T. So negative 1, 1, 3. That's my answer. So now, I want you to take a moment. You might have to do this one on loose leaf paper. We don't have a whole lot of space left. But I want you to try to answer this one. All right, we'll just do equations 1, 2, and 3. Now, we'll go ahead and pause it and try that one out. Okay, I had to work this one on a separate paper just because I didn't have room. But equations 1, 2, and 3, by the way, the final answer for this should have been x is negative 2, y is positive 2, z is negative 1. All right, so to do this, I said, hey, let's cancel out x's in equations 1 and 2. You may have tried a different method. Doesn't have to be x's, but I did x's. So I did 1 and 2, cancel out the x's. I was left with y plus 4z equals negative 2. Now, I have to cancel out x again. We used 1 and 2. I said, hey, 2 and 3, one's positive, one's negative. So I used equations 2 and 3, and I had to distribute a 5 to equation 2 because I wanted a 5x here to cancel out negative 5x. So if you distribute 5 to equation 2, it becomes 5x minus 5y plus 15z equals negative 35. Combine that with equation 3, cancel out those x's, you're left with negative 6y plus 11z equals negative 23. So that's step 2. Step 1, we had y plus 4z equal negative 2. Step 2, negative 6y plus 11z equal negative 23. Now put them together. If you put those equations together, I just brought this one down here, y plus 4z equal negative 2, nothing cancels. I need it to cancel, so I said, hey, if I want to cancel out y's, I need a 6 right here. So I distributed 6 to this whole equation. Gave me 6y plus 24z equal negative 12. And I just brought that other one down. Negative 6y plus 11z equal negative 23. And this time, the y's cancel. 24z plus 11z give me 35z equal to negative 35. Once you get to this point, it's easy. All right, then you just divide by the 35, you have z equals negative 1. Then once I know that, once I know the first part of my answer, again, go back to one of the little equations. I use that one. All right, y plus 4z equal negative 2. So plug in negative 1 in for that z. Y plus 4 times negative 1 gives me negative 2. And then work that out. 4 times negative 1, that's negative 4. Add the 4, negative 2 plus 4, you get y equals positive 2. And then once you know that, you know z is negative 1, you know y is positive 2. Go back to any of these three big equations. Doesn't matter which one. I used the second one. And I said x minus y was 2 plus 3 times the z number is negative 1 equals negative 7. And just solve that. 3 times negative 1 is negative 3. Negative 2 and negative 3 give me negative 5. X minus 5 equals negative 7. Add the 5 gives me negative 2. So I know now that x is negative 2. Again, put them in alphabetical order. Negative 2, positive 2, negative 1. That's my answer. So now we have some problems y'all need to try. I want you to work those out. And good luck.